Thank you. And good morning, and thank you to Naventus to invite us to this gathering today. We are a company producing green carbon, green oil, and green gas. Let's see, and I have this one. I'm sure that you all know about the renewables logic. Basically, if we dig carbon, if we pump oil, or if we take gas from the fossil sources, which were produced 50 million years ago, and we release that CO2 in the atmosphere, we get global warming. The alternative to that is, of course, to produce carbon, oil, and gas from biomass, and that constitutes a circle of CO2. The tree will absorb the carbon dioxide, it will end up in the leaves, in the stem wood, and once cut down, we can release it again, and that's the carbon cycle. So basically, the problem with global warming is not the emission of CO2 per se. It's really the source of the CO2 that constitutes the problem. So fossil replaced by biomass is a solution to most of the countries, or the companies, the fossil companies' problems. You are, of course, free to stop me whenever you want with questions. We have decided to focus on the metallurgical industry with our product, and we are a build, own, and operate company. So we don't sell technology, but we sell the commodities produced by our processes. And if we look at Sweden, the metallurgical companies account for 40% of the CO2 emissions, of the industry's emissions, and 15% of the total. And of that, the steel and iron production is about 1/3. The other metallurgy companies, the copper, the lead, the zinc, the silicon, is another 1/3 of the total emissions. And those are the focus areas for us, highly specialized carbon to replace fossil carbon. As feedstock, we mainly use stem wood from the forest, meaning, in our case, residuals from sawmills, which is sawdust. About 12 to 14% of the entire log will end up being sawdust, and that is the prime source of feedstock for us. So in Sweden, we generate around 1.7 million tons every year. And basically all of that is today combusted in big furnaces to produce hot water and district heating. A bit about us. We are privately owned by the founders, people working for the company, and some industrial and financial investors. Among them, Bayer Capital or Bayer Invest. We have Carbomax, which is the only, I think, fossil carbon company in Sweden. We have Carl Palmstierna. I don't know whether he is here, but I hope he comes. We dare to say we are a very experienced team from the process industry and business development. Our business model is to produce commodities, to sell carbon in the way that the steel mills and the copper mills want it, to sell the oil to the refineries, and to sell the gas to anyone that needs gas, and as a substitute to natural gas. So our whole business model is replacing the fossil commodities with green ones. And in that, we have a very, very active IPR strategy to safeguard our findings and to make sure that those assets are held within the company. The company structure is that we have a development company, Envigas Technology AB. We have today one production company up in Skellefteå, and I'll come back to that. And we are in the process of starting more, because there is a huge opportunity in this market. That's an interesting ad from one of the owners and one of the customers, which is very nice. We have an experienced team of the board of directors. I'm the chairman. We have Joachim Karlsson from Nordic Capital. We have Carl Palmstierna. I don't think he needs any further presentation. Per-Olof Wedin was the CEO for Sveaskog for many years and retired last fall. Søren Eriksson is the man behind biodiesel in Sweden. He was the one, he was working for Preem, and he founded companies like, vad heter de i Piteå? Sunpine. We have a management team with our CEO, Tobias Brink, and if you stand up, some people can talk to you later on. We have a very interesting scientific advisory board with a professor from Gerrit Brehm from Twente in Holland, Gupta from the University of Maryland, and Dr. Axel Funke from Karlsruhe in Germany. All these three experts in their individual area within our process, basically. This is the value creation process. So from 1 ton of biomass, meaning sawdust, we produce about close to 300 kilo of biocarbon. And if we post-process that biocarbon, we can get a very similar specification to fossil coke, which has a world market value and is a commodity for the steel and other metallurgic industries. The remain is 750 kilo of pyrolysis gas, can either be condensed into bio-oil, 145 kilo, which we can send to Preem or ST1 to be converted into diesel, into gasoline or jet fuel, in their hydrocracker. That's a conventional technology that they have developed and built to handle tall oil from the forest industries. And the remains is between 600 and 750 kilos of non-condensed gas can be converted into biomethane, which is biogas, which is really natural gas, so CH4, and carbon dioxide. Both are valuable commodities on the market. Carbon dioxide is, of course, if it is pure, it's an interesting commodity for breweries, it's an interesting commodity for the industry, and you can bury it deep in the ground to make a negative carbon sink. But we can also turn the whole process around and produce, instead of biomethane, produce biohydrogen. And green hydrogen is possibly the future fuel for us. We have seen a range of different vehicles coming onto the streets using hydrogen and fuel cells. But we have seen initiatives such as the one SSAB is doing with the hybrid process, where they use hydrogen instead of carbon to reduce iron into steel. So there will be a market for hydrogen. We just don't know when. There is already a market for biogas. So the value creation process shows that if we, for each ton of biomass we inject into the process, we get a value of about 1,700 Swedish crowns for the carbon. We get about 900 Swedish crown for the bio-oil, and we get about close to 800 Swedish crowns for the gas. If we sell the oil to the refinery, we get way more than that, almost double. In the biomethane production, we get, of course, more, and if we produce hydrogen instead, this looks even better from a financial point of view. So in principle, 1,000 Swedish crowns in is about 4,000 Swedish crowns out. That's the value creation chain we are working with. We have we are building one production plant right now. As a matter of fact, it will be in operation in Skellefteå within a month's time from now. And that's the first in our case. And for those of you that are interested in the full P&L or the balance sheet, you can have a look at this later on. It's a bit detailed to go into from here and now. But it's a very profitable operation. So our focus is the metallurgical industry in the Nordic countries. And we have to remember that they are using today somewhere in the vicinity of 5 million tons of carbon annually. 5 million tons. That is a CO2 emission of about 20 million tons. So they are a big portion of the problem we have right now with global warming, and they know it. The initiative from SSAB to switch from carbon-based reduction of the iron ore into hydrogen reduction of the iron ore to steel is a very good example of that. And SSAB has, since they announced that they were going for fossil-free iron, received the pressure from the market. As a matter of fact, there is a big European car manufacturer that is pushing SSAB to deliver fossil-free steel for cars 2026. So the pressure from the market is coming, and the metallurgical industry is feeling it, and they are responding to it. We are the first industrial scale producer of biocoke, bio-oils, and biogas on the market. Biogas, well, there has been a lot of biogas produced over the years. But in a thermochemical process, we are the first one. We work with direct sales. We work with all the big steel and metallurgy companies in Sweden for the time being. We'll continue into Norway and Finland once we have the tonnage available to support their needs. So the total addressable market in Sweden alone is about 3 million tons. In the Nordic countries, about 5. And we will produce, in the plant we are building right now in Skellefteå, about 10,000 tons. So we need to build more, and we need to build larger. But there is no shortage of biomass for this. So the prices computed are, of course, comparable to the fossil, plus the emission rights, plus a small green premium. In Sweden today, we are working with almost all the metallurgical companies, such as SSAB, Boliden, Höganäs, Elkem in Norway doing silicon. There are lots of these companies, and almost all of them are either on their way to implement green carbon or will do it. So finally, unless anyone has a question, we work with bio-based project with a huge CO2 reduction impact. And this is to replace fossil equivalents. It is really a green tech investment with a very limited technology risk, since we are not developing the technology. We are a process plant. Instead of producing paper in a chemical way, we are in a thermochemical way producing carbon, oil, and gas. We think we consider ourselves to be having competent investors, board and management. It is a global opportunity with a very large potential in local markets. even though our focus is on the Nordic countries. It's a very interesting input-output margin ratio. It's actually much better than a pulp mill. And there is a future possibility to refine the carbon, the oil, and the gas into much higher values. So we can take this carbon and we can do very interesting other commodities from it. We can take the oil and do some very, very interesting commodities from that in the future. And of course, the gas is interesting for us. So we are a strange bird in this room because we are a process industry. We are not a technology company. Questions, anyone?
I'll help you with that because we need runners with the microphones. Please join me here, center stage. Let's start with the app, and then you could, if you have questions in the room, you could just prepare them, and Emma will join you with a microphone. Let's see. How much is the carbon footprint? How much can the carbon footprint of steel be reduced with biocoke?
Well, a steel mill is a complex. They are emitting CO2 from other sources than carbon. They are basically doing it from carbon, from fossil carbon, and from natural gas. They need a lot of heat to produce steel. And we can replace both of those. So in principle, we can do them, we can do them carbon neutral.
And we know in Sweden the carbon footprint from this industry is roughly about 10%, I think.
15, yeah.
15, yes, even worse. So that's a lot of possibilities there. Another question here. Could you please explain, as you would to a 5-year-old, the different CO2 impacts from fossil and bio-based fuels?
Well, we have to go back to this
the first slide.
The CO2 circle, yes. Because the fossil we are using today, highly subsidized to dig up carbon or to pump up oil or to take natural gas from the wells, was really produced 50 million years ago.
50 million.
50 million years
50.
ago. And we have been using that now for 150 years. And now we see the cost. Whereas if we take anything organic and treat that thermochemically, we can take that carbon, that oil, and that gas and sell it to the industry.
And basically that's the above ground, what we have as biological materials now, not something that has been compressed and stored underground.
It could be trees, of course in Sweden it is trees, or residues from trees. In other countries it could be agro-residues, which are more abundant in other parts of the world.
Thank you. What is the difference between Envigas and Cortus?
Well, Cortus is, they are producing an energy gas. They are doing gasification, and we are doing something called pyrolysis. Anyone that have read about the old coal mills, coal milor,
the ones up in the northern parts of Sweden,
that is pyrolysis. So this has been around forever, but it was sort of forgotten. And we took it up, we created a modern, highly advanced process out of it.
And now you also get the biochar out of this process.
Yes.
And the biochar could be used in agriculture, for instance.
Could be, but we are focusing on the metallurgical industry. It could be used in the agriculture as a soil amendment. It could be used as activated carbon. It could be used as a lot of different things, but we are focusing on the metallurgical industry because we want to have a highly qualified customer with a highly qualified and high specification product.
Is it important that your facilities are located close to your clients or the source of the biomass?
No, it should be located fairly close to the biomass, because the energy density of the carbon oil makes it more suitable to transport than the feedstock itself.
When will your bureau plant be fully up and running?
It is up and running. It has been running for over a year now in a small scale. About 5.
I think fully.
The small one is 500 tons per year. Now the big one, the big plant is coming up producing 10,000 tons a year, and that will be up and running within about a month,
About
one and a
month.
half years.
Okay, excellent. Let's see, do we have any questions in the room that would like to use their hands and their...
Any metallurgical experts here? No.
All right. So I have a final question.
Here
Well, there
is
was one, great. Okay, let's get a hand microphone here.
So I understand the first slide, meaning I understand that, okay, if we would only use the above ground biomass, so to say, like, I get that logic. What I don't see, I don't understand how converting biomass into CO2, like it's still additional CO2. So how would this be a green technology?
Well, if you take, the tree that you cut down to burn has absorbed CO2 during its lifetime. When you burn it, you will emit the same amount again that will be absorbed by the next tree.
Is
It's going
sawdust,
around and around.
is sawdust always burnt?
Pardon?
Nowadays, is sawdust always burnt?
Burnt.
Yes. Yes.
I see.
Yes. Yeah. It's always burnt. There is no other use for it. I mean, you can do fiberboard, but that's a limited market nowadays. So if you look at Sweden as a market, it is burnt to do district heating.
I understand. Thank you.
And there is also the aspect of the biochar that is also basically bionegative.
Yes, if you
Climate
dig it
negative.
into the
Climate
ground,
negative,
it would
yes.
be a negative emission. But we think that replacing a fossil emitter is more clever than digging carbon down into the ground and allow them to continue with fossil emissions.
Any more questions? Well, thank you very much, Kurt.
Thank
And
you.
best of luck with your work.
Thank you.